This video will cover section 2.10, other applications of optimization. Specifically, we will cover elasticity of demand. Given a demand function that gives Q in terms of P, that is the number of units as a function of the price. Up until this point, we've seen price as a function of the number of units. Demand will depend on price. Then the elasticity of demand E is the absolute value of P over Q times the derivative of Q with respect to P. So if you have the demand function, it's the derivative of the demand function with respect to the input variable P. Since demand is a decreasing function of P, and this should make sense realistically that as we increase price, the demand of some object or unit should go down. The derivative is negative. That's why we have absolute values, so that our elasticity will always be positive. If elasticity is always positive, that means that it's always larger than 0. And if we look at if E is less than 1, we're considering if E is less than 1, but also greater than 0. Then we say that demand is inelastic. When demand is inelastic and our elasticity is less than 1, we want to raise prices to increase revenue. If E is larger than 1, we say the demand is elastic. In this case, if we raise prices, it'll decrease revenue. And if the elasticity equals 1, we say the demand is unitary. E equals 1 of the critical points of the revenue function. Interpretation of the elasticity is that if the price increases by 1%, the demand will decrease by the elasticity as a percent. Let's look at a practice problem. The demand function for Alicia's oven mitts that we discussed in the previous video is given by Q equals negative 8P plus 80, where Q is the number of oven mitts and P is the price in dollars. This is our demand function because we have the number of units as a function of the price. We want to find the elasticity of demand when P equals 750. Will revenue increase if Alicia raises her price from 750? So that would be if the elasticity is inelastic. So we'll want to find E first and then compare it to 1. So remember, the elasticity is found by taking the absolute value of the price over the quantity times the derivative of the demand function with respect to the price. So we'll need to find the derivative of our demand function with respect to price. This ends up just being negative 8 since our demand function is a linear function. So in general, the elasticity is P over Q times negative 8. Now, we know that the price that we're considering the elasticity of is 750, but we'll need to find the demand when price is 750, so we'll evaluate our demand function when P is 750. So the demand will be 20 when the price is set to 750. Let's plug in this price and this quantity of units into our elasticity function. We're still looking at the absolute value of 750 divided by 20 times negative 8. Then the elasticity will be 3, which is larger than 1. From the previous slide, when the elasticity is larger than 1, we say that the demand is elastic and raising prices will decrease revenue. So revenue will decrease if Alicia raises her price from 750. So just to reiterate, since demand is elastic, raising prices will decrease revenue. That concludes the Chapter 2 material. The next series of videos will get into integrals.